In the quiet vastness of space, there exists an idea, softly imagined, barely understood, called the white hole. It is the mirror image of a black hole, a place where instead of swallowing everything that comes near, it expels matter and light endlessly, refusing to let anything in. Think of it as the universe exhaling, releasing what was once trapped, scattering stardust and energy into the cold dark. Its existence, though only theoretical, feels like a dream the cosmos might have whispered to itself, a balance to all that disappears beyond event horizons. The white hole is not an object we have seen with our eyes or telescopes, but one we've met in equations. Einstein's field equations, when reflected in time, give birth to this opposite of darkness, an opening where time reverses, and things are thrown outward. In the mathematics, it makes sense, a perfect counterweight to the black hole's insatiable hunger. But in the physical world, we have yet to find one, as though they exist in another rhythm of the universe, one hidden beneath the visible patterns of creation and decay. To understand a white hole, imagine space bending inward until nothing escapes, then imagine it bending outward, so nothing can enter. The event horizon becomes a glowing boundary, not a trap but a gate that rejects intrusion. Light, instead of being captured, bursts outward in eternal refusal. It is a place of defiance, of pure energy radiating outward from some deep cosmic wound, where gravity runs backward, and time itself might flow differently, or perhaps, not at all in the way we know. Physicists speak of them softly, because even in theory, white holes make the universe seem stranger, less certain. They suggest that maybe every black hole, at its deepest point, connects to a bridge across space-time, where what is devoured here is expelled elsewhere. Some imagine it like an hourglass, the black hole funneling inward, and the white hole pouring outward, two ends of one impossible tunnel. It is beautiful, haunting, and profoundly unreachable. But if a white hole exists, it cannot last long in the violent universe we know. The smallest speck of dust, the tiniest photon drifting too close, would destroy the delicate balance, collapsing the white hole into instability. Its very nature of not letting anything in means it could not survive in the busy, swirling chaos of galaxies. It could only live in the silence between moments, where nothing disturbs it, a fleeting dream of creation before being undone by reality. Some scientists think white holes could have existed only in the earliest seconds after the Big Bang, when everything was wild and unformed, when laws we take as absolute were still soft and flexible. Perhaps they were part of the universe's first breaths, brief, shining flares of expulsion before the cosmos found its calm rhythm. If so, then their echoes might still drift in the radiation and structure of space, traces too faint for our instruments, like the perfume of a vanished star. Others have gone further and whispered that our own Big Bang could have been a white hole, the outpouring of energy from a collapsed universe before ours. In that vision, creation and destruction are not opposites but partners in an endless cycle, each universe feeding the next. A black hole in one cosmos becomes a white hole in another, a cosmic recycling of everything, stitched together by the fabric of time itself folding and unfolding in silence. If you think of it this way, a white hole is a promise that nothing truly disappears. What goes in somewhere, someday, comes out somewhere else. Energy changes, matter transforms, and space bends, but the total story continues. It's a comforting thought, isn't it? That even the darkness of a black hole is not final, but part of a greater rhythm, a universe breathing in and out across eternity. The mystery of white holes lies in their impossibility. They are born from perfect mathematics, yet the universe rarely honors perfection. Reality loves imperfection, the slight imbalance that leads to stars, to life, to thought. Perhaps that's why white holes have not been seen. They may be too perfect, too symmetrical to exist in a world that thrives on asymmetry and entropy. Yet, in their impossibility, they remind us of what physics can dream. When we think of them, we are invited to see time differently. To imagine moments not as a straight line but as loops, spirals, folds where endings become beginnings. A white hole, then, is not a contradiction but a continuation, the other side of a coin that we only ever see from one face. Somewhere, beyond the observable edge, it may shine an impossible dawn born from endless night. There is something poetic about the thought of a place that only gives, never takes. In a universe where gravity is the great consumer, pulling everything toward stillness, A white hole is an act of release. It is generosity written into spacetime, a constant letting go, a refusal to hold. In that way, even as a theory, it feels human, as if the cosmos itself understands the beauty of release. White holes also stir fear in the heart of reason. If they exist, then time itself might have regions where it cannot move forward, where the arrow of causality breaks. Things could appear without origin, energy without source, existence without explanation. And yet, these ideas are not chaos, they are glimpses of how vast and layered reality might truly be. The unknown here is not hostile, only beyond reach. In the deep, quiet hours of the night, thinking of white holes can feel like listening to a lullaby sung by physics itself, a slow, soft melody of symmetry and possibility. They are not loud discoveries, not fiery explosions, but whispers of elegance, of how the universe balances its extremes. For every in-breath of gravity, there may be an out-breath of release. Astronomers still search, pointing telescopes into the void, studying gamma bursts and faint flashes that might betray a white hole signature. Nothing confirmed yet, but sometimes, when strange bursts appear and vanish, the thought crosses their minds, what if that was one? What if for an instant, we saw the universe exhale again? If we could witness one, it might look like a sphere of pure brilliance, light cascading outward in all directions, space itself bending and trembling at its edge. No matter entering, only leaving. Around it, a silence unlike any other, because nothing could disturb its surface. The scene would be serene, like watching creation rewind and unfold all at once. In a sense, white holes belong more to philosophy than physics. They invite reflection on opposites, on how every pull must have a push, every end a beginning. Even if they never exist in the material sense, they shape our understanding of what could be. They are reminders that imagination and science are not rivals, but partners in exploring the infinite. Their beauty lies in their defiance of certainty. Every black hole discovered strengthens the theory that white holes should, mathematically, exist. And yet, every observation of space refuses to show one. It is as if the universe is playing hide and seek with its own reflection, keeping one half of its truth tucked away. Some imagine a dying black hole, evaporating through Hawking radiation, could end as a white hole, a final flash as all that was trapped is released back into the cosmos. If so, then every black hole's death would be a rebirth, a luminous sigh after eons of silence. The end of darkness giving way to light, not as destruction, but completion. White holes challenge us to see beyond experience, beyond what instruments can measure. They remind us that the language of the universe is written not only in what we can touch, but in what we can conceive. That even in the emptiness, there are stories waiting to unfold, stories of balance, symmetry, and eternal exchange. And so, we whisper about them. Not as facts, but as possibilities, ghosts of equations, dreams of spacetime. They may never reveal themselves, but the thought of them makes the universe feel more whole, more alive. A place not only of endings, but of continuations. A cosmos that both swallows and gives back, forever breathing, forever in motion. In that whisper of thought, in that fragile symmetry, the white hole remains a soft glow at the edge of imagination, where the universe tells us quietly that even the void has its light. It begins with curiosity, the same force that has always pulled humanity toward the unknown. When scientists first encountered the terrifying beauty of black holes in Einstein's equations, they also discovered something equally strange, a mirror image that emerged naturally when the math was reversed in time. A white hole wasn't invented out of fantasy, but born out of logic. It was a whisper from the equations themselves, saying, if something can only take, something must also give. And that symmetry intrigued the minds who dared to listen. Einstein's theory of general relativity is a playground of opposites and balances. The same way matter bends spacetime to create gravity, the same way energy and motion twist the geometry of the universe, every effect suggests a counterpart. When black holes appeared as solutions, sucking all matter inward, the equations did not forbid the opposite, a region that expels matter outward endlessly. It wasn't wishful thinking, it was mathematical honesty. Scientists imagined white holes because the universe, on paper, seemed capable of them. The seed of the idea was planted by Karl Schwarzschild, who found the first exact solution to Einstein's equations in 1916. That solution, describing a black hole, also allowed, if one followed it carefully, another region beyond the singularity, a place where time flowed in reverse. It was strange, unphysical perhaps, but it existed in the math. Later, thinkers like Kruskal and Sekeres explored this fully, revealing that a complete black hole solution naturally contains a white hole on the opposite side, connected through a wormhole-like structure. To ignore it would be to ignore part of reality's possible geometry. Scientists didn't imagine white holes as fairy tales, but as necessary consequences. For the equations to remain symmetrical, time itself had to be two-faced, able to run both forward and backward, at least in theory. A black hole's event horizon, which allows entry but forbids exit, has a twin that forbids entry but allows only exit. That perfect inversion was mesmerizing, a glimpse of the universe's hidden balance. It's as though space-time, when viewed completely, breathes in with black holes and breathes out with white holes. For decades, no one believed such entities could physically exist. They seemed too fragile, too idealized. But science thrives on questions, not certainty. Even if nature never built one, the concept of a white hole helped physicists explore deeper questions about time, entropy, and causality. It became a tool to stretch the imagination of mathematics and see how far the rules of physics could bend before they broke. Each impossible concept in theory often births a new discovery in understanding. The 20th century was a time when physics flirted with paradoxes. Time travel, antimatter, quantum uncertainty all seemed to emerge from the language of equations rather than the evidence of eyes. White holes joined this strange family, showing that the universe's logic was more poetic than straightforward. They existed not to be seen, necessarily, but to test the boundaries of what could be thought. Scientists imagined them because without imagination, theory becomes a cage, and progress halts at the edge of the known. Later, as quantum physics deepened, the question of black hole evaporation arose. Stephen Hawking's calculations showed that black holes could lose mass and energy over time, glowing faintly as they did. If a black hole can radiate, could its final stage resemble a white hole bursting out what it had consumed over cosmic ages? The idea returned, not as mere symmetry, but as a possible ending written into the life cycle of gravity itself. The imagination of scientists, once dismissed as abstract, began to sound prophetic. Another reason scientists imagine white holes is because they need answers to what happens beyond singularities. The center of a black hole, where matter compresses infinitely, is a problem physics cannot yet solve. The laws break there, screaming for completion. White holes might offer that missing piece, a way for information to escape, for balance to be restored. They might not exist as visible objects, but as concepts that preserve the integrity of cosmic law, ensuring that nothing, not even data, is truly lost. In cosmology, white holes offer another kind of beauty. They can be models for the birth of universes. When scientists trace our own cosmos backward through time, they arrive at a singularity too, the Big Bang. It is eerily similar to what a white hole would be, an explosion of matter and energy from a single point, expanding outward, unstoppable. Was our entire universe born from a white hole? The question isn't just poetic, it's mathematical. And math, in its cold precision, sometimes leads us to truths that sound like myths. Imagination in science is not fantasy, it is exploration. When a physicist imagines a white hole, they are not inventing magic, they are exploring the edges of known truth. Every great discovery begins as something absurd. The atom was absurd. Quantum tunneling was absurd. The idea of invisible singularities devouring light was absurd too, until evidence proved them real. White holes might someday walk the same path, from mathematics to observation, from dream to data. Scientists imagine white holes also because nature tends to balance extremes. In physics, symmetry is sacred. There is positive and negative charge, matter and antimatter, expansion and contraction. Black holes are the ultimate sink, white holes would be the ultimate source. Their existence would make the universe a perfectly balanced equation, a cosmic yin and yang where every act of absorption has its release. Even if we never find one, believing in their possibility keeps our picture of reality whole. The equations that predict white holes also predict wormholes, tunnels connecting distant regions of spacetime. Some scientists imagine that what enters a black hole could emerge elsewhere through a white hole. This isn't just fantasy, it's an exploration of relativity's geometry. These wormholes might collapse too quickly to travel through, but the very thought of them reshapes how we see distance and connection in the universe. It reminds us that space might not be a void, but a woven fabric, full of hidden threads. White holes are also imagined to preserve the conservation of information, a sacred principle in physics. Black holes seem to destroy information, swallowing it into oblivion, but that breaks quantum law. If white holes exist as the outlets for this lost data, then the universe remains lawful, consistent. Scientists imagine them not because they want to, but because the integrity of physics almost demands that something like them should exist. They may be nature's hidden bookkeeping system, where every secret eventually returns. Beyond equations, white holes test the boundaries of human thought. To imagine one, you must reverse your intuition. You must picture gravity not as attraction, but repulsion, not as darkness swallowing light, but light expelling darkness. That act of mental reversal stretches the imagination in the same way the cosmos stretches time. Scientists need such exercises. They keep the mind supple, daring, able to approach the impossible with calm curiosity. The fascination also lies in their paradox. White holes, if real, cannot form naturally in the current universe. They would require perfect conditions that no physical process could create. Yet, perhaps at the dawn of time, when everything was chaos and creation intertwined, such perfection briefly existed. Scientists imagine them to peek into those primordial moments, to understand what the first seconds after the Big Bang might have felt like when physics itself was young and experimental. Every generation of physicists inherits the unknowns of the last. White holes remain one of those elegant mysteries passed down, unsolved but never forgotten. They appear in advanced cosmological models, in quantum gravity papers, and even in speculative theories of spacetime foam. Like distant myths of gods or lost lands, they represent something unreachable but meaningful, a sign that the story of the universe isn't finished. Even modern models like loop quantum gravity and holographic cosmology bring white holes back into the conversation. In these frameworks, black holes might not end in singularities at all but bounce, reborn as white holes releasing what was once trapped. The cycle of collapse and explosion could be the heartbeat of spacetime itself. Scientists imagine this not for wonder's sake, but to reconcile the contradictions between quantum mechanics and relativity. In that reconciliation, imagination becomes a tool of survival. Without it, the two great pillars of physics stand forever apart. White holes, strange as they are, could be the bridge showing how gravity and quantum rules coexist, how matter's journey inward has an outward echo. The image of a dying black hole transforming into a radiant white hole gives hope that even cosmic death is not destruction but transition. It is also in the nature of science to question what seems impossible. Every no in the universe invites a what if. Scientists imagine white holes because they represent the ultimate what if the end is not the end? What if every collapse is paired with an expansion somewhere else? It is a hopeful symmetry, a faith in the balance of existence written in the very code of spacetime. To imagine a white hole is to practice humility before the unknown. It is to admit that we may not yet understand how time truly works, how beginnings and endings weave together. Scientists, even in their rigor, dream. They dream mathematically, precisely, but it is still dreaming. A white hole is one of those dreams, half logic, half longing, that fills the gaps in our knowledge with wonder. And so, they continue to imagine them. Not to escape reality, but to see it more completely. Each time an equation hints at symmetry, each time an anomaly appears in the sky, the question returns. Maybe, just maybe, somewhere in the deep folds of the cosmos, there is a place where the universe breathes out again. A place that refuses darkness, releasing light forever, and reminding us that every end deserves its opposite. A black hole is a hunger that never ends, a pit of spacetime that swallows light and sound and the memory of all that touches it. To imagine a partner to such a thing feels impossible, and yet, the equations demand it. The white hole rises in theory as its reflection, a cosmic act of balance, an exhalation to the black hole's endless inhale. It exists not in the cold reach of telescopes but in the delicate folds of thought, where the universe's symmetry finds room to breathe. It is the dream to the black hole's nightmare, a mathematical echo of fairness written across eternity. They are opposites not in destruction and creation alone, but in their very direction through time. A black hole pulls inward, its arrows of time sinking toward a singular fate, while a white hole thrusts outward, its moments exploding away from a single origin. In one, nothing escapes, in the other, nothing enters. And between them, scientists sense the possibility of connection, a secret tunnel called an Einstein-Rosen bridge, perhaps, through which matter flows from one to the other like breath between lungs. It is elegant, tragic, and perhaps only possible in dreams. The white hole would be everything a black hole is not: radiant, defiant, and free. Where a black hole traps light in an eternal silence, a white hole would spill it endlessly into the dark, glowing without exhaustion. It would be the mirror universe's sunrise, a point in space where time's flow refuses to collapse. But the balance is fragile. The slightest intrusion of matter would destroy its purity, tearing apart the very spacetime that keeps it stable. And so, even as an idea, it feels lonely, forever untouchable, living only in thought. Physicists imagine the two as partners bound by fate, two ends of the same cosmic thread. What one devours, the other could release. Some have wondered if every black hole in our universe is linked to a white hole in another, creating a vast cosmic recycling system that keeps matter and energy in eternal motion. Through that invisible dance, the universe might cleanse itself. What disappears in one corner reappears in another, transformed but never lost. The symmetry is almost too perfect to be real, and yet, beauty in physics often hides truth. The partnership of black and white holes also speaks to something deeper in us, a longing for balance, for order within the chaos. We see in them the same cycle that governs everything: death and rebirth, implosion and explosion, silence and sound. The black hole swallows stars, the white hole gives birth to them. In their interplay lies a cosmic heartbeat, one side pulsing inward, the other outward, a rhythm too vast for human perception but felt through the equations that whisper across space-time. In their theoretical connection, time folds into itself. If one were to travel into a black hole, impossible though it may be, they might emerge from a white hole elsewhere, ejected into a new region of the cosmos, or perhaps into another universe entirely. Such a journey would not be one of survival, but of transformation. The traveler would be torn apart, information scattered, and yet in the mathematics, something continues, reborn, reassembled on the other side, a ghost carried by the geometry of spacetime itself. Even as partners, they are unequal. Black holes have been seen, measured, heard through the ripples they send across space. White holes, meanwhile, remain silent, only predicted, never witnessed. Their absence makes the black hole's presence feel heavier, as though one twin was lost before birth. Yet, in their imbalance lies mystery, and mystery is the lifeblood of science. To search for the unseen half of reality is not madness, it is the essence of exploration. Some physicists have imagined that the white hole's existence is hidden within the black hole's life cycle itself. Perhaps, when a black hole has consumed all it can and evaporates through Hawking radiation, it transforms. The energy trapped within might explode outward as a white hole, returning everything to the universe in one final, blinding sigh. In that instant, the partners unite, their identities dissolving, one feeding the other in a cosmic act of self-renewal. If this is true, then every black hole is not a dead end but a waiting rebirth. The white hole is simply time turned inside out, the same object viewed from a future we cannot yet reach. The idea feels both terrifying and tender, that the darkness we fear may one day blossom into light, that collapse is not the end but the pause before expansion. It's the kind of symmetry the universe seems to love, even if it hides it from our eyes. In storytelling and philosophy, the black hole and white hole are archetypes of consumption and release, of holding and letting go. Where one clings endlessly, the other gives endlessly. This duality is not just a feature of physics, it is a reflection of all cycles that sustain existence. Even within ourselves, there are black holes of memory and grief, and white holes of forgiveness and creativity. The cosmos, it seems, writes its metaphors directly into its structure. To imagine them together is to imagine a universe that never wastes. Every photon swallowed, every planet consumed, every collapsing star, all of it perhaps stored, processed, and returned somewhere else. In that view, destruction becomes merely one side of creation, not its opposite. The partnership between black and white holes could be the ultimate expression of cosmic sustainability, matter forever circulating, never truly ending, only changing its form across infinite time. Scientists, though guided by equations, are often poets at heart. The symmetry between black and white holes touches something emotional in their reasoning. It satisfies the human need for closure, for the universe to make sense. It says that nothing vanishes into meaninglessness, everything that falls returns, everything dark has its dawn. Even if such symmetry never proves real, it comforts the mind that seeks harmony in the laws of nature. And yet, not all are convinced. Many argue that the universe doesn't owe us balance, that reality is not obliged to be fair. The black hole's dominance in observation, and the white hole's absence, could simply mean nature chose one path over another. Perhaps creation does not need a mirror to destruction. But even in doubt, scientists keep the idea alive not because it must be true, but because it keeps the imagination wide open. The thought of a white hole glowing somewhere, unknown, is too beautiful to discard. Somewhere beyond our detection, it might be flinging ancient matter across an empty region of space, the remnants of galaxies reborn as dust and light. Perhaps those particles drift for eons, joining new stars, fueling new worlds. In this vision, the partnership continues in secret, its effects felt though the participants remain unseen. There are also those who suspect that the two are connected by quantum threads, that at their deepest levels, information never truly vanishes but tunnels between them through dimensions we cannot perceive. The black hole and white hole, then, would not just be partners across space but across reality itself, one existing as the inverse reflection of the other in a hidden, higher geometry of the cosmos. Even in the silence of equations, their union feels like a story. The black hole devours, the white hole restores. One is the midnight of physics, the other its dawn. The balance may be imaginary, but it teaches us something about the completeness of nature's design, that every extreme implies its counterpart, every abyss hints at escape. This is the poetry embedded in the cold structure of mathematics. If black holes are the universe's memory, white holes are its forgetting. Through one, history is preserved, compressed beyond recognition. Through the other, it is released, scattered into new beginnings. This eternal partnership could be the mechanism of renewal, ensuring that the cosmos never stagnates, that even decay becomes creation in another form. Such a partnership, even theoretical, gives motion to eternity. And in that partnership lies a reflection of existence itself. Just as the cosmos expands and contracts, life too is made of opposites, holding on and letting go, creation and dissolution, thought and silence. The black hole and white hole are grand metaphors written in the physics of spacetime, reminders that every end hides a beginning, every collapse a pulse of renewal. When physicists describe them, there's often a strange tenderness in their tone. They speak of horizons and singularities like poets describing oceans and storms. They know that, in truth, these partners may never be found, yet their existence in theory gives meaning to the darkness. It says that even the most absolute void has its counterpart, a light that will one day return what was lost. The idea that the universe could be built upon such pairs, black and white holes, particles and antiparticles, matter and energy, suggests a hidden rhythm behind chaos. It whispers that the cosmos might not be random at all, but musical, harmonic in its balance. To imagine white holes, then, is to listen for the other half of that song, faint and far but real in the language of possibility. Whether they exist or not, white holes complete the story. They ensure that the black hole's tale is not merely of destruction but of cycle, of endless motion through time's fabric. Without them, the story ends in silence. With them, it continues in light. The two are bound, even if only in the imagination of physicists and dreamers. In their dance, the universe feels whole. And so, when scientists speak of black holes, they cannot help but whisper of white ones. Even if never seen, The idea glows faintly behind every discovery, every shadowed photograph of an event horizon. For every darkness the cosmos shows us, perhaps there is light somewhere else, pouring forth unseen, a partner to black holes, if only an idea, but eternal in its purpose. There is a quiet problem at the heart of physics, a whisper that refuses to be ignored. When something falls into a black hole, what happens to the information it carries? Every particle, every bit of quantum detail, seems to vanish beyond the event horizon. But quantum mechanics tells us that information cannot be destroyed, it must persist, transformed perhaps, but never erased. This is the information paradox, a haunting contradiction that keeps scientists awake at night. And softly, in the background, the idea of a white hole glows, a possible key to unlocking that paradox. Imagine this: everything a black hole swallows is not lost forever but held, waiting. Over unimaginable spans of time, the black hole shrinks through Hawking radiation, its energy leaking back into the cosmos. But what if, when it reaches its final moment, all the information trapped inside is released, not as random heat, but as a structured outpouring? That final burst could be the white hole phase, a mirror transformation where the universe restores what was hidden. It's speculation, yes, but one grounded in the desperate logic of cosmic balance. Physicists like Carlo Rovelli and Hal Haggard have explored this idea, suggesting that when a black hole dies, it could bounce, transitioning into a white hole that releases the stored data. In this scenario, the information isn't destroyed, it simply takes a detour through time. The collapse becomes a rebound, the singularity softens, and what was trapped finds its way back into existence. It's a beautiful thought, like seeing death turn into birth, a quiet assurance that nothing truly disappears into silence. To imagine a black hole transforming into a white hole requires bending our concept of time itself. Inside a black hole, time and space trade roles, the future becomes inward, leading only toward the singularity. But if the singularity could rebound, time might reverse, turning collapse into expansion. From our perspective, it might look like an ancient explosion, a burst of light and matter emerging from nowhere. This inversion of time could be the bridge between loss and recovery, a mathematical mercy written into spacetime itself. The information paradox has long been one of physics' most poetic nightmares. Stephen Hawking himself once believed information was lost forever in black holes, but later, quantum reasoning convinced him otherwise. He proposed that subtle correlations in the radiation might preserve the information, smeared across the cosmos like an invisible signature. Yet, some scientists feel that explanation lacks closure. The white hole idea, in contrast, offers narrative harmony. It completes the story, giving the universe a way to exhale after eons of holding its breath. If white holes exist as endpoints of black holes, then information isn't destroyed, it is delayed. What we perceive as disappearance could simply be time's deep storage system. The universe, instead of erasing its past, might hide it in gravitational vaults, to be released later in a gentler form. This paints reality not as careless but patient, keeping its records intact beneath the flow of entropy. It's a romantic vision of physics, one that honors both the rigor of equations and the tenderness of cosmic continuity. Quantum gravity theories, like loop quantum gravity, suggest that spacetime itself is made of discrete loops, tiny grains of geometry. When a black hole collapses beyond a certain threshold, these loops resist infinite compression, creating a bounce instead of a singularity. That bounce could appear to the outside world as a white hole, emerging after immense time dilation. From the inside, it might happen in a blink; from the outside, it could take billions of years. The universe, it seems, plays with time like music, stretching and compressing its notes across eternity. The concept is speculative, but gently so. It doesn't violate known laws, it extends them. It asks, what if nature already knows how to preserve information, and we just haven't seen her method yet? The black hole's event horizon could be the storage surface, encoding everything that falls in, while the eventual white hole serves as the release mechanism. The cosmos becomes a grand archive, where nothing is deleted, only compressed, encrypted, and eventually returned. This view changes how we see destruction. The death of a star collapsing into a black hole would no longer be a final act, but a transformation, a process of refinement. The matter and information, stripped of identity, would one day re-emerge as raw potential, scattered light, or energy feeding the birth of new worlds. It's a cosmic recycling that feels both scientifically elegant and emotionally soothing, turning loss into a kind of waiting. Even if white holes are never directly observed, they provide a philosophical comfort. They suggest that the universe is not a careless consumer but a careful curator. Every story, every atom, every quantum spin carries history, and that history is kept safe somewhere within the deep machinery of spacetime. The information puzzle becomes not a tragedy of loss, but a mystery of patience, the universe storing its memories until the right moment to share them again. Still, there are skeptics, and rightfully so. The idea of white holes challenges conventional thermodynamics. If nothing can enter them, how can they form naturally? Would they violate entropy's steady rise, the arrow of time that guides all things toward disorder? Perhaps, say some physicists, a white hole isn't an object that exists in normal time but an event, a momentary reversal during the black hole's final evaporation, a pulse of order rising briefly from chaos before fading away. In that fleeting moment, the information could escape, carried in the subtle correlations of particles and photons, weaving the universe's fabric back together. The white hole, then, is not a structure but a phase, a transition point where physics briefly reveals its deeper symmetry. The laws of nature, usually one-directional, momentarily glance back at themselves before continuing forward again. This delicate balance between loss and return may be the universe's quietest secret. The gentle speculation continues: if every black hole ends as a white hole, then perhaps the Big Bang itself was once a black hole in another universe. Our entire cosmos could be the release phase of something that collapsed elsewhere, a grand white hole blooming into existence. In that picture, the information of a previous universe isn't gone, it's transformed into the structure of ours. Each cosmos gives birth to the next through cycles of collapse and renewal, a chain of existence stretching infinitely backward and forward. Such a view reframes the information paradox as a story of inheritance. The white hole becomes the bridge of continuity between worlds, ensuring that each generation of universes carries traces of its predecessors. Galaxies, stars, consciousness all might be echoes of information recycled from ancient realities. It is a bold idea, but boldness has always been the quiet pulse beneath discovery. Even speculation, when done gently, widens the horizon of what we dare to understand. At the heart of this idea lies the principle of conservation, the universe's promise to keep its ledger balanced. Information, like energy, cannot vanish. It may change form, hide, scatter, or evolve, but it remains. The black hole absorbs it, the white hole releases it, and between them lies the poetry of transformation. It's as though the cosmos itself believes in the sanctity of memory, unwilling to let anything truly be forgotten. In recent years, quantum theorists have revisited this connection, studying whether black hole radiation could indeed carry encoded information that later manifests as a white hole event. Simulations suggest that under certain models, the math allows such behavior without contradiction. Though we cannot yet see it, the possibility hums beneath the surface of spacetime, waiting for the tools of future generations to catch its faint light. This perspective also touches something spiritual in science, the idea that order persists even through chaos. It suggests that decay and collapse are not acts of waste but of reorganization. A white hole's emergence would be the universe saying, "Here, nothing was lost. It only became different." The information puzzle, then, becomes not a question of disappearance but of transformation, a cosmic patience that spans beyond our sense of time. The beauty of the white hole theory lies in its restraint. It doesn't claim certainty, it merely opens a window. It invites us to imagine the universe as a self-correcting system, where symmetry is not perfection but continuity. Every collapse has a rebound, every loss a quiet return. In this gentleness of speculation, science brushes against philosophy, and the boundary between knowledge and wonder blurs softly. Even if white holes never manifest, their conceptual presence shapes how we ask questions. They force physicists to reconsider what inside and outside mean, what it means for something to be gone. They make us face the limits of observation, reminding us that reality may hide most of itself behind horizons we cannot cross. And yet, even in that limitation, there's grace, the grace of mystery, the promise of more to come. Perhaps, one distant day, we'll detect a burst of energy so strange, so sudden, that it matches what a dying black hole's transformation would produce. It would be faint, brief, but filled with encoded whispers of everything once lost inside. If that day comes, the white hole will cease to be theory and become revelation, a confirmation that the universe keeps its word, that its stories always find their way home. Until then, the idea remains an act of faith disguised as physics, a gentle faith that the universe is whole, that even the darkest holes in reality hold within them the seeds of light. The information paradox may remain unsolved for centuries, but the white hole stands as a symbol of hope in the equations, a mathematical promise that the cosmos forgets nothing. It may be that we never fully grasp how information escapes or transforms. The truth might be hidden in dimensions beyond our reach, folded into the quantum foam of space-time. But even partial understanding brings comfort. It tells us that the quest itself, the act of seeking meaning in the vastness, is its own kind of resolution. And so, scientists keep imagining, calculating, dreaming quietly between proofs. They treat the paradox not as a wall but as a veil, behind which something elegant waits. Maybe, somewhere beyond the cosmic horizon, a white hole is already shining, its light faint but eternal, carrying the data of everything that ever fell away. Maybe the universe, in its softest moments, is whispering back what was once lost. In that whisper, the puzzle softens. The black hole and white hole no longer oppose each other but complete one another. The paradox becomes poetry, and the universe, still mysterious, still unreachable, feels a little more forgiving. When scientists and dreamers look back to the first instant of everything, they often find their minds drawn to the image of a white hole. It's as if the birth of the universe itself could be imagined as a single, enormous exhalation, a point that rejected all confinement, where everything that would ever exist rushed outward from infinite density into boundless space. In that moment, all matter, energy, time, and possibility would have streamed forth, a grand eruption of existence that feels almost like the perfect reflection of what a white hole would be. The Big Bang, in many ways, behaves like the ultimate white hole. It is a place in time, not in space, where the universe seemed to explode outward from nothing. Nothing could enter that moment, it was the beginning of causality itself. Every galaxy, every atom, every ripple of light began its journey from there, pouring into the void like water rushing into new channels. The comparison to a white hole feels poetic, yet hauntingly logical. Both describe expansion, not collapse. Imagine if a black hole in some ancient universe had reached the end of its story. Its core compressed beyond comprehension, matter trapped beyond retrieval. Then, at some point, perhaps through quantum effects we barely understand, it erupts elsewhere, in another spacetime, reborn as a white hole. What was consumed in one reality becomes the seed of another. That concept turns the idea of destruction into creation, and it whispers that the universe might recycle itself through cosmic heartbeats. Such a picture reshapes our understanding of beginnings. We often imagine the Big Bang as a singular creation event, unique and final. But if it were linked to a previous universe through a black-to-white hole bridge, then beginnings and endings are not separate, they are one continuous rhythm. The universe could be pulsing through eternities, collapsing into black holes and blooming again through white ones. Death and birth, endlessly folded together. In that soft and speculative vision, a white hole becomes not just an object but a metaphor for renewal. It tells us that every point of absolute compression might eventually release, that no form of confinement lasts forever. Even the densest gravity may one day yield, letting go of what it once held. This possibility makes the universe seem more organic, like a living being breathing through cycles of collapse and expansion. If this were true, then the cosmos might never truly have a beginning, only transitions. Each universe could inherit the ashes of the last, reimagined in the explosion of a white hole. Matter and energy are not created from nothing but reborn from somewhere else, across an unfathomable divide. This would mean that what we call the Big Bang was not the first sound of creation but an echo of an older melody, reverberating endlessly through space-time. The beauty of linking white holes to beginnings lies in its symmetry. In physics, symmetry often reveals truth. It is the quiet law that balances opposites. For every contraction, an expansion. For every gravitational pull inward, a counterforce outward. The white hole, in its elegance, completes the story of gravity, giving an outward answer to inward collapse. It helps restore a sense of harmony to the chaotic sprawl of cosmic birth. Picture, for a moment, the earliest seconds of the universe: searing heat, light flooding the void, particles colliding, expanding, separating. In that chaotic beauty, a white hole's image seems to fit, an unstoppable outward flow where matter and radiation escape into the open. Perhaps not from within spacetime, but as the very act that defines it. It's soothing to think that the universe began not with destruction, but with release. White holes also give us a poetic way to think about creation without needing something from nothing. The concept avoids the unsettling question of how existence began from a void, by suggesting that it never truly did. The matter we see might have simply crossed a boundary, transformed, reborn, expelled from another realm. The Big Bang would then be not the first note, but a bridge between cosmic verses. To many, this idea feels comforting. It replaces the loneliness of a singular creation event with the continuity of an infinite cycle. Every galaxy could be the remnant of a story that once collapsed elsewhere. Every atom in your body might have once belonged to a star in a universe now gone, carried through the impossible channel of a white hole's expulsion. It turns the coldness of cosmology into something tender, a reminder that we are part of an unbroken lineage of creation. Of course, this remains speculation, a dream wrapped in mathematics. No telescope has glimpsed a white hole, no trace of one has been verified. Yet, the thought persists because it fills a deep need in our understanding, the desire for balance, for continuity. If black holes are endings, something must carry the story forward. White holes, even imagined, give that sense of completion. In this view, the Big Bang's expansion is not a random event, but a necessary consequence of cosmic equilibrium. For every implosion, an explosion. For every collapse, an eruption. The universe becomes a grand tapestry of exchange, energy and matter endlessly traded between phases of compression and liberation. And within that pattern, a white hole is the spark of new beginnings, a gentle undoing of all that was trapped before. Some physicists have tried to express this mathematically through models of bouncing cosmologies. In these theories, the universe contracts under gravity until it reaches a critical point, then rebounds, the contraction's endpoint becomes the next expansion's beginning. This bounce behaves much like a white hole, the moment when gravity's pull reverses into push, when collapse transforms into creation. It is a story of the cosmos refusing to end. If the Big Bang was such a rebound, it means time itself may have flipped direction at that moment. What we call the past might have another version of time flowing oppositely, hidden beyond the bounce. Somewhere beyond that unreachable point, another universe could be aging in reverse, its own black holes feeding the birth of ours. It's a dizzying, beautiful symmetry, one that dissolves the boundaries between endings and beginnings. It also reminds us that perhaps there is no such thing as nothing. Even in the void before creation, quantum fields might have hummed softly, storing potential. The white hole could then be the release of that built-up energy, an inevitable eruption of existence waiting to happen. The stillness before time would not be empty but pregnant with the possibility of everything. Thinking of white holes in this way reshapes how we see our place in the cosmos. We are not inhabitants of a random explosion, but travelers within an infinite cycle of renewal. The stars above us are not one-time miracles but recurring motifs, reappearing in different forms across eternities. The white hole, then, becomes a symbol of reassurance that the universe knows how to begin again. And if every end gives rise to a beginning, then perhaps even our universe will one day collapse inward, only to bloom again through another white hole's outpouring. The cycle would continue. Endlessly, the cosmos never dying, merely changing rhythm. That thought brings a strange peace. Creation is never lost, merely reborn. Some imagine this rebirth as a kind of memory carried through physics itself. Information, energy, structure all folded and preserved in the deep layers of spacetime, waiting to emerge anew. The white hole, then, is a vault unlocking, the universe remembering itself after eons of silence. That's a quiet, almost spiritual idea, that existence has memory, that every dawn recalls an older light. In this gentle cosmology, even chaos has purpose. The violence of supernovae, the collapse of stars into black holes, the distortion of time all serve the endless process of renewal. Every fall inward prepares for an eventual release. A white hole represents that moment of grace, when the universe lets go, giving back what was once hidden. For thinkers who ponder such cycles, the white hole is not only a physical concept but a symbol of cosmic forgiveness. It means that nothing, not even light swallowed by darkness, is lost forever. There is always another side, another chance, another emergence. In that way, white holes make the universe feel profoundly humane, an endless pattern of falling and rising, of loss and renewal. When seen through this lens, our own beginnings as humans mirror the cosmos's beginnings. We too emerge from collapse, from stars that lived, burned, and fell into themselves. We are, in a way, the universe's white hole moment, the re-expression of matter into thought, the rebirth of what once was in new, conscious form. The cosmic and the personal intertwine beautifully here. So, when we picture the universe beginning, we can imagine it softly, not as a chaotic blast, but as a serene expansion. Like a white hole blooming in silence, releasing all that was once confined. The galaxies drifting outward are the petals of that great cosmic flower, unfolding in slow motion through billions of years. And perhaps, someday, when the stars fade and the last black hole collapses, another universe will awaken, bright and new, spilling forth from another white hole's light. It is not the end, but the continuation of an infinite breath, the universe dreaming itself awake, again and again, in endless, luminous renewal. When we whisper about white holes, we often find another secret drifting alongside them, the idea of bridges. Not the kind made of wood or metal, but of space and time themselves, curving inward and outward like tunnels between worlds. Physicists call them Einstein-Rosen bridges, or more familiarly, wormholes. And if white holes exist, they might form one mouth of such a bridge, the opposite end of a black hole's insatiable pull. One devours, the other releases, and between them stretches a corridor of impossible geometry, narrow, twisting, perhaps even timeless. To imagine this softly is to picture space as fabric, pliant, gentle, alive. A black hole presses inward, stretching it so tightly that it pierces itself. On the other side of that tear, a white hole might bloom, expelling what the black hole once took in. The two ends are like breath and sigh, inhale and exhale, creating a cosmic balance between consumption and release. In that quiet symmetry lies the possibility of a bridge, a passage through the dark unknown, linking distant realms of the same vast cosmos. For decades, this idea has hovered at the edges of physics, too elegant to dismiss, too unstable to trust. Wormholes, if they could exist, might allow shortcuts through space, even through time. But they would require conditions beyond anything we can produce: negative energy, exotic matter that repels gravity instead of attracting it. The universe seems reluctant to permit such freedom. Perhaps it guards its secrets behind barriers of natural law. Yet still, the equations suggest the door isn't locked entirely, only hidden. The beauty of this idea lies in how it unites opposites. The black hole, often seen as destruction incarnate, could in truth be the beginning of something new. If it connects to a white hole, then nothing swallowed is truly lost, it simply moves elsewhere, emerging renewed. This offers not only a bridge between points in space, but between ideas, between death and rebirth, between loss and return. It is a reminder that in the deepest physics, endings and beginnings may not be so different after all. To walk, even in imagination, through such a bridge would be to move beyond understanding. Inside, gravity might twist directions, time might loop or pause, and light could behave like a dream, bending around corners, dimming without fading. One might see echoes of other worlds, other stars, flickering through folds of space like reflections on rippling water. And at the far end, the emergence into light, the white hole's radiance, would feel like stepping into creation itself. But of course, there is danger in such beauty. The math tells us these bridges, if they exist, are fragile things. The smallest disturbance could collapse them. A single atom of ordinary matter entering could make the tunnel pinch shut, severing the connection in an instant. It's as if the universe allows only the idea of them, not the act. They may be meant for thought, not for travel, glimpses of what spacetime is capable of, but not what it will permit us to use. Still, scientists dream gently of stable bridges. Theoretical physicists toy with equations involving quantum effects and exotic matter, wondering if there might be loopholes in the laws of gravity. Could dark energy, that mysterious force accelerating cosmic expansion, provide the needed repulsion? Could it hold a wormhole open long enough to glimpse another side? The answers are unknown, but the questions themselves keep our curiosity alive, pulling us deeper into wonder. There's something almost poetic about the symmetry of it all. The black hole as the universe's inward motion, collapse, silence, secrecy. The white hole as its outward motion, release, light, revelation. Between them, the bridge stands as balance, the still point in the turning of the cosmos. It's as if the universe writes poetry in its geometry, folding space into verses that rhyme across time. If these bridges are real, they could mean that distant corners of the universe are closer than they appear, not separated by billions of light years, but joined through unseen tunnels. Perhaps the cosmos is not an expanse but a weave, threads looping and crossing in higher dimensions, hidden from ordinary sight. And if we could see it all at once, we might find that every black hole is simply a doorway waiting for its white twin to open. For now, though, we explore these bridges with equations, not engines. Theories like quantum gravity and loop cosmology try to describe what happens beyond the event horizon, where space folds too tightly for classical physics to follow. Some of these ideas suggest that instead of ending in a singularity, a black hole's core could bounce, forming a white hole on the other side. In that moment, the bridge becomes not just a path through space, but through reality itself. It's soothing, somehow, to imagine the universe this way, not as a void punctuated by disasters, but as a continuous, breathing structure, where every collapse leads somewhere, and every explosion comes from something. Wormholes, in this sense, become less like science fiction and more like metaphors for cosmic continuity, the threads that tie existence together in a seamless pattern. Even if they never exist in physical form, the concept of such bridges changes how we think about everything. They remind us that connection is possible across distances that seem infinite. They whisper that there might always be another side, another light, another escape, that the universe is not a maze of traps, but a network of possibilities. Some thinkers even wonder if these bridges could explain mysterious cosmic phenomena, sudden bursts of energy, unusual gamma flashes, or unaccounted cosmic rays. Could these be hints, echoes of white holes momentarily revealing themselves, spilling matter through hidden links from elsewhere? It's speculation, but it stirs the imagination, inviting us to see the sky as full of subtle messages. And perhaps the most delicate part of the idea is what it says about unity. Black holes and white holes, collapse and expansion, consumption and creation all are parts of a single process, different faces of the same cosmic coin. The bridge between them is not just a tunnel through space, but a symbol of balance, showing us that even opposites can belong together. There is humility in this vision. It tells us that the universe is not built only on destruction, but on exchange. What falls inward somewhere may emerge outward elsewhere. The darkness and the light are not enemies, they are partners in the grand flow of matter and meaning. The bridge is the whisper between them, a soft voice reminding us that every loss may carry the seed of return. If we could listen closely enough, perhaps the cosmos would sound like breathing in through the black holes, out through the white ones. The bridges would be the lungs, the invisible corridors through which creation circulates itself. It is a deeply comforting picture, one that replaces fear with rhythm, and chaos with quiet balance. Wormholes, white holes, and black holes together form a kind of trinity in cosmic imagination, the collapse, the passage, and the release. None can be fully understood without the others. Even in their theoretical uncertainty, they represent the poetry of physics, where mathematics becomes a language of awe. There's also a gentle sadness in knowing that such bridges, if they exist, may forever be beyond our reach. We can map their possibility, but not their path. The universe may allow them to exist only as dreams within itself, glimpses of what could be, seen only through the lens of imagination. Yet, even as abstractions, they enrich our sense of what space can hold. In the end, whether or not these exotic bridges are real, they help us see the cosmos differently. They transform black holes from symbols of annihilation into part of a larger story, one of motion, connection, and endless exchange. And that story feels far more alive, far more gentle, than the cold voids we once feared. So, we keep the thought alive, softly, reverently, that perhaps somewhere in the quiet folds of spacetime, a bridge does exist. Hidden in shadow, untouched by time, connecting darkness to light. A path where everything lost finds its way home again, carried through the universe's most secret doors, into the soft, radiant outflow of a waiting white hole. In the silence of the universe, light sometimes comes suddenly, sharp, bright, and gone almost as quickly as it appears. Astronomers have long puzzled over these brief, unexplainable bursts, powerful flashes of radiation that flare for a moment, then fade into darkness. They have names like gamma-ray bursts, fast radio bursts, or transient outflows, mysterious signals from deep space that don't fit neatly into the usual categories of dying stars or colliding galaxies. And somewhere in that uncertainty, the whisper of a theory stirs. What if some of these strange lights are white holes waking for an instant before fading forever? It is a fragile idea, not shouted but murmured, because it rests at the edge of physics and imagination. A white hole, by its nature, is unstable. It cannot exist long in the dense and busy universe we know. Any disturbance, any particle approaching its event horizon, could collapse it. But what if that collapse, that brief flicker of existence, produced an enormous surge of radiation, the last breath of an impossible object? That momentary release could look exactly like the flashes we detect, brilliant, brief, and unexplained. Some cosmologists have gently suggested that certain gamma-ray bursts might be such events, the death throes of white holes appearing for the briefest instant. Not as stable stars or exploding supernovae, but as one-time cosmic eruptions, where something hidden for eons finally lets go of its stored energy. In this view, the white hole doesn't live long enough to be seen directly. It announces itself with one radiant outburst, like a single heartbeat of the universe echoing across billions of light years. The light from these events is strange, sometimes brighter than entire galaxies, yet lasting only seconds. Traditional explanations work for some: collapsing stars, merging neutron stars, the release of magnetar energy. But others defy easy understanding. The idea of a white hole gives those stubborn mysteries a home, a model that doesn't claim certainty, but offers hope that even in rare, unpredictable bursts, the universe might still be showing us new physics. If a white hole were to appear, it would likely release enormous amounts of high-energy radiation, along with a flood of matter that had been trapped elsewhere, perhaps inside a black hole's core. The result would be a blinding flash, an instant of energy pouring outward in all directions, untethered by time. Then, as quickly as it came, the phenomenon would vanish, leaving behind no trace but the memory of light. For astronomers watching from Earth, it would look exactly like the unpredictable cosmic flares that still puzzle us today. There's an emotional tenderness in this possibility that the universe, so vast and indifferent, could still surprise us with glimpses of its hidden symmetry. Each flash, brief and bright, could be a message from a process we've never truly witnessed, the other side of collapse, the exhale following billions of years of cosmic silence. In that sense, even if white holes remain theoretical, their imagined presence keeps curiosity alive, a soft hope that we've not yet seen all that space has to offer. Some physicists, cautious yet curious, have proposed that these transient flashes might also represent the end stage of black holes. Over unimaginable timescales, black holes slowly evaporate through Hawking radiation, their mass decreasing until only energy remains. When the last bit of trapped matter escapes, could that release appear as a brief, brilliant white hole flash? The equations don't forbid it, they only hide it within limits of time far beyond our comprehension. If such black hole death flashes occur, they would be scattered sparsely across the cosmos, too rare for regular observation but powerful enough to reach us from billions of light-years away. Detecting one would mean catching the final moment of a process that began near the dawn of time, a kind of cosmic afterglow of everything that ever fell into that hole. The thought is staggering, yet strangely peaceful. Even black holes, the most final of entities, might end in light. This cautious hope has inspired new studies of unexplained bursts, cross-checking data, comparing energies, tracing frequencies. Some researchers look for patterns that might distinguish a white hole flash from known sources, a different light curve, a unique polarization, or a signature wavelength. So far, nothing certain has emerged. But even the act of looking pushes our instruments and imagination further, deepening our conversation with the cosmos. It's easy to forget how little of the universe we truly see. Most of its signals pass unnoticed, its light swallowed by distance or dust, its meaning blurred by noise. That we can even detect these brief flashes is astonishing, like hearing a whisper from across a canyon older than time itself. The possibility that they might be white holes makes that whisper even more sacred, a fleeting note from the other side of gravity's song. In quiet observatories across Earth and in orbit above it, astronomers wait for these flickers, single points of brilliance that vanish as quickly as they appear. They record their coordinates, their duration, their color. Each is a mystery, but each holds the potential to rewrite what we know. The hope, though cautious, never fades. Perhaps one day, a flash will appear that fits no known model, that sings in a different frequency, the first whisper of a white hole revealing itself. There's a kind of poetry in imagining that the rarest bursts of light might not come from destruction, but from release. Most cosmic explosions are violent endings, stars dying, galaxies colliding. But a white hole would be the opposite, the light of liberation, energy escaping after ages of confinement. That inversion gives the mystery a quiet grace, the idea that even in the most powerful events, there is gentleness, a letting go rather than a tearing apart. It's this balance that draws scientists back to the theory, again and again. They know the odds are small, the evidence thin, the mathematics treacherous. Yet, they also know that the universe has a history of surprising us, of hiding beauty behind improbability. Once, black holes themselves were just theory, thought impossible, even absurd. Now we photograph their shadows. If that dream became real, who can say what others might follow? If white holes truly flicker in the dark, their messages would be subtle, their moments brief. They would not announce themselves in grandeur, but in fleeting brilliance, a light too fast for the human eye, but not for the patience of machines that watch the sky. Perhaps one already has, hidden in archived data, mistaken for something else. The story of discovery often begins this way, with a mystery that only later reveals its depth. For now, the white hole remains an idea, fragile, beautiful, incomplete. It sits among the other strange theories that bridge science and wonder, time loops, multiverse, quantum echoes. But unlike many, this one feels tied to something we can almost touch, the real flashes of light that our telescopes already see. Each one a question, each one a possibility. In the quiet rhythm of observation, hope moves slowly. The night sky is patient, and the universe reveals itself in its own time. But the thought that those flashes could be brief openings, cosmic doors that shine and close, gives meaning to our waiting. We are not merely looking for explosions, we are listening for the moments when space breathes. If a white hole ever truly appeared, it would likely not stay long enough to be studied. Its life would be a fraction of a second, its light fading before even the fastest instruments could react. Yet that instant would change everything. It would mean the universe still holds untold stories, that gravity, the oldest force, still has new tricks to reveal. That in its depths, creation still finds ways to shine. Even in their absence, the idea of white holes changes the way we look at light. Every mysterious flash becomes a question rather than an answer. Every burst of brilliance becomes a possibility. And that curiosity, that soft, persistent wondering, is what keeps humanity gazing upward. So, we continue, cautiously hopeful. Each flash recorded, each anomaly studied, each whisper of light preserved. Somewhere among them may lie the signature of a white hole, a sign that even in the silence of space, there are moments of rebirth. Not destruction, but release. Not chaos, but the universe, gently exhaling. When we whisper about white holes, we are not just speaking of matter and light, we are also brushing against time itself. Few ideas in physics touch the deep flow of time as tenderly, or as strangely, as this one. A white hole, if it exists, would not simply reverse gravity, it would reverse the direction of time's arrow within its region. It would show what the universe looks like when entropy, the measure of disorder and decay, runs backward, when the future becomes the past, and the act of release replaces the act of collapse. In that sense, A white hole is less an object and more a mirror for time's meaning. Entropy is the quiet current that pulls everything forward. Stars burn, metals rust, heat spreads, and the universe grows more disordered with every heartbeat of cosmic time. This irreversible drift from order to chaos defines the direction of time itself. We know what past and future mean because one holds lower entropy and the other, higher. The black hole fits perfectly into this flow. It consumes, hides, and adds to the universe's growing disorder. But a white hole, by its very nature, defies it. It decreases entropy locally, pushing matter outward in organized, radiant streams. It's as though a white hole represents a region where time's current runs in reverse. Not backward in the sense of rewinding memories or undoing history, but in the mathematical sense where the order of cause and effect flips, and what we call before and after trade places. Inside its boundary, everything that escapes was always destined to do so. Nothing can enter, nothing can change the outcome. It is a frozen scene of inevitability, the future already written, pouring outward. To think of time this way is to soften its rigidity. A white hole makes us wonder, is the arrow of time absolute, or just local? Could the universe contain regions where time behaves differently, expanding, contracting, or even standing still? In the presence of intense gravity, time slows. Near a black hole, it nearly stops. Perhaps near a white hole, time accelerates, the ultimate release, not only of energy but of the moment itself, rushing forward faster than we can imagine. In thermodynamics, entropy always rises because the universe prefers probability, the messy over the tidy, the diffuse over the concentrated. A white hole would stand as a breathtaking exception, a region where order increases, where structure blooms from chaos. But such a region cannot easily persist. It would be too delicate, too precise, too opposed to the natural drift of reality. That fragility might explain why we do not see white holes lasting in the sky. The laws of entropy would crush them almost as soon as they appear. And yet, their existence in theory still teaches us something profound. It tells us that the universe's laws are not inherently one-sided, they allow for both directions, both flows of time. What makes our world asymmetrical is not the equations, but the conditions, the low entropy beginning of the cosmos. The Big Bang, in this light, behaves like the ultimate white hole, the source of all order, the fountainhead of time's forward motion. So, when we imagine a white hole, we are not defying physics, we are peering at the part of it we do not experience. We are contemplating what time would look like if the universe were viewed from its reverse. In that reversed realm, what we call decay would appear as creation, what we call heat death would appear as rebirth. Energy would not dissipate but condense. Stars would not burn out but reassemble, glowing backward into brilliance. It is not a world we could live in, but it helps us see the symmetry that underlies everything we know. Einstein's field equations, when viewed without the constraints of time's one-way arrow, treat black holes and white holes as twins, mathematically identical, differing only by direction. It is we, with our entropic senses and forward-drifting existence, who see them as opposites. From the universe's point of view, perhaps both are merely flows inward and outward, gathering and dispersing, two halves of the same breath. In a sense, studying white holes helps scientists test the boundaries of the second law of thermodynamics. That law, that entropy always increases, is one of the most reliable we know, and yet it is statistical, not absolute. There are small, rare fluctuations where order increases by chance, even in our world. A white hole might be an extreme version of that, a temporary, immense fluctuation where order briefly triumphs, before dissolving back into the universe's general disorder. This concept also helps us think about information, another subtle partner of entropy. In a black hole, information appears lost, locked behind an event horizon that lets nothing out. But if every black hole connects to a white hole, then the information may not vanish at all, it may reappear elsewhere, released in a different form. In that way, white holes may protect one of physics' most sacred principles, that information, like energy, is never truly destroyed. Time and entropy, in this view, are less enemies than dance partners. One sets the rhythm, the other the direction. The white hole, rare and fragile though it may be, is the counterstep, a pirouette backward, a flourish of reversed motion in the choreography of the cosmos. And even if it cannot survive for long, The idea of it adds beauty to the pattern, making the dance feel whole. There's something calming in knowing that physics allows such symmetry. It suggests that the universe itself is balanced, that for every collapse there might be expansion, for every consuming dark, a releasing light. Even the most final-seeming events are not absolute endings, but transformations within the larger movement of energy, entropy, and time. In our daily lives, we experience only one direction, forward, into greater complexity and disorder. But the white hole lets us imagine the opposite, what it would mean for things to grow simpler, cleaner, more ordered with time. It reminds us that what we call irreversible is only so because of scale, not law. On the grandest levels, the universe remains symmetric, capable of running either way. Some physicists suspect that white holes might appear not as large celestial events, but as microscopic, quantum-scale phenomena, brief, flickering reversals of entropy in the foam of spacetime itself. Tiny bubbles where time behaves differently, appearing and vanishing in less than a heartbeat. If true, it would mean that the reversal white holes represent is not myth but woven into the very texture of reality, always there, too small for us to see. Others go further, suggesting that time itself may be emergent, not fundamental, but a product of entropy. If that's the case, then white holes aren't just oddities, they are keys to understanding how time is born from change. In places where entropy runs backward, time itself might unravel, leaving behind only the pure relationships between energy and space, timeless physics beneath all motion. This turns the white hole into more than a curiosity, it becomes a laboratory of imagination. A tool for exploring why the universe has direction at all. Why we remember the past but not the future. Why heat flows outward, not inward. These questions, though simple, remain some of the deepest mysteries in all of science, and the white hole, serene, defiant, ephemeral, stands as their most beautiful mirror. Entropy, in its quiet way, drives everything, the birth of stars, the decay of atoms, the flow of thought. The white hole, even as an idea, asks us to consider what lies beyond that drive. Is there a state of being where the universe exhales fully, where all that was disordered becomes whole again? The question is not one we can answer, but one that reminds us how incomplete our understanding still is. To view time through the white hole is to glimpse eternity not as endless duration, but as perfect symmetry, the balance of beginnings and endings, expansion and contraction, birth and dissolution. It's a kind of peace, hidden in the heart of chaos. The universe, through this lens, is not a march toward decay, but a cycle of giving and receiving, forever renewing itself in ways we can only partly see. And so, the white hole remains not just as a theoretical solution, but as a tool for thinking gently about time. It invites humility, the awareness that the flow we call inevitable may only be a small part of a greater pattern. It reminds us that the arrow of time, like all things in the cosmos, might one day bend, turn, and softly begin again. There are ideas in physics that feel less like discoveries and more like gifts, quiet offerings from the language of mathematics to the human imagination. White holes belong to that rare kind. Even if they are never seen, even if they remain entirely theoretical, they have already changed how we think about the universe. They stretch the boundaries of what seems possible, gently teaching us that reality might be broader, softer, and more reversible than our senses suggest. They remind us that imagination, when guided by reason, is not just dreaming, it is exploration in its purest form. From the first equations that hinted at them, white holes have lived in the delicate space between proof and poetry. They are the mirror reflection of black holes, born from the same mathematics that describes the crushing collapse of stars. And yet, while black holes drag everything inward, white holes let everything go, a quiet symmetry, a whisper of balance in a universe filled with extremes. That idea alone is worth treasuring, the notion that even the cosmos might seek equilibrium, that every devouring dark may have a counterpart of release. Physicists may debate their existence, but in doing so, they open new corridors of thought. White holes force us to confront the deepest assumptions about space and time, that they must always move forward, that entropy must always rise, that beginnings are forever separate from endings. Through the lens of this single idea, all those rules become flexible, inviting reinterpretation. And in that flexibility, imagination finds room to breathe. To think of a white hole is to play with symmetry on a cosmic scale. It's to look at the black hole, an object of perfect finality, and ask, what if the story runs in reverse? What if matter, instead of falling forever inward, were expelled outward in an unstoppable flow? What if every collapse carries within it a promise of renewal? These are not trivial fantasies, they are the seeds of progress. Many great advances in science began with questions that sounded poetic before they became practical. Even the act of imagining a white hole changes our relationship with mystery. It shows that uncertainty is not something to be feared but cherished, a space for curiosity to live. In this way, the concept becomes more than a scientific hypothesis, it becomes a meditation on the unknown. Like the edge of a dream you can almost recall, it teases the intellect while calming the heart, reminding us that not all beauty in science is meant to be proven. Some is meant simply to be wondered at. Mathematically, white holes emerge naturally when black holes are described in their most complete form. The equations of general relativity are timeless, they allow for both collapse and expansion, for both absorption and release. When we trace those lines backward, we find not contradiction but completion. The white hole balances the equation, a reminder that even in the harshest physical laws, there is room for harmony. For theorists, this symmetry is a playground, one where ideas about wormholes, the multiverse, and quantum gravity come alive. Some imagine white holes as the exits of tunnels that black holes begin, cosmic bridges linking distant parts of space or even different universes. Others see them as echoes of the universe's birth, hints of how time and matter first unfolded. Whether or not these visions ever align with observation, they push the mind to travel further than before. In this sense, white holes nourish the same spirit that drove humans to map stars, build telescopes, and send ships into the dark. They carry forward the belief that understanding is not just about knowing, but about imagining what might be. Even if no telescope ever captures one, the thought of their existence has already given physics new ways to talk about energy, information, and the fabric of time. That is a kind of success, a quiet triumph of thought. It's easy to think of failed theories as mistakes, but in truth, each one adds to the depth of our understanding. White holes may never shine in the sky, but their equations have deepened our grasp of symmetry and conservation. They've revealed how closely intertwined gravity and thermodynamics are, how entropy shapes the flow of both heat and time. They are proof that even unconfirmed ideas can leave lasting imprints on science's evolution. For the dreamers among physicists, the white hole offers a rare comfort. It suggests that even the universe's most destructive forces may have counterparts of creation. That the same mathematics that describes darkness and collapse can also describe light and release. This balance between despair and hope is as emotional as it is intellectual, a quiet affirmation that the universe, though fierce, may not be without grace. And for the storytellers, the ones who blend science and wonder, the white hole is pure treasure. It invites metaphors of rebirth, of cycles, of time looping softly back on itself. It becomes a symbol for cosmic renewal, for the possibility that nothing is ever truly lost. Through it, the cold equations of relativity take on the warmth of myth, turning the universe itself into a story of endless giving and returning. There's a generosity in the idea of a white hole. It does not hoard, it releases. Where black holes are possessive, swallowing all, white holes are open-handed, scattering light, matter, and perhaps even time itself. Whether real or imagined, that symbolism resonates. It touches something deeply human, our wish that destruction and creation are never truly separate, that every ending contains a beginning. Some physicists have compared white holes to thought experiments in their purest form, not meant to be captured, only to illuminate the terrain around them. Like lighthouses on the edge of knowledge, they shine where direct evidence cannot yet reach. They remind science that imagination is not a distraction but a compass, pointing toward possibilities unseen. Even now, new theories in quantum gravity and loop cosmology occasionally revive the white hole, reshaping it into forms that might one day be tested. These attempts often fail, but each failure is rich in insight. Each shows how fragile and yet fertile the boundary between known and unknown can be. In that way, white holes continue to serve their purpose as sparks that keep curiosity burning. What makes them special is not their certainty, but their invitation. They invite us to think in terms of dualities, absorption and emission, life and death, time and reversal. They remind us that opposites are not enemies but complements. And that perhaps, in the grandest view, the universe itself is a vast equilibrium between the two. Even the silence surrounding white holes, the fact that we may never find them, is part of their allure. Their mystery preserves something essential to science: humility. The reminder that for all our equations and machines, the cosmos will always hold secrets just beyond reach. And maybe that's as it should be, a universe too vast to be fully mapped, too beautiful to be fully known. So yes, white holes may remain unproven, perhaps even impossible. But their legacy is undeniable. They've pushed us to think harder about time, about entropy, about what it means to begin and to end. They've connected physics with philosophy, turning cold theory into reflection, into awe. In the quiet of theory, they shimmer like mirages, real or not, they matter. Because science needs both discovery and dream, both data and daring. The white hole, whether it ever exists or not, is proof that imagination itself can be a tool of understanding, not an escape from it. And perhaps that is their truest gift, not to be found, but to be wondered about. To remind us that the universe's greatest treasures are sometimes the questions themselves, the ones that stretch our minds just enough to glimpse infinity and whisper, softly, what if? There is a hush that comes at the end of every great cosmic idea, a soft quiet, like the universe taking a long, deep breath. The thought of white holes belongs to that hush. Whether they exist or not, their possibility brings something gentle to the heart of an otherwise vast and lonely cosmos. They suggest that not everything ends in darkness, that not all gravity is devouring, that not every fall must go on forever. They remind us that even in the cold equations of physics, there can be space for balance, for things that release as much as they take. In that quiet balance, there is comfort. If black holes are symbols of inevitability, of endings, silence, and the boundaries of knowledge, then white holes are the whisper of what might come after. They are the cosmic exhale following the long inhale of collapse. Even if they never appear in the sky, even if no telescope ever sees their glow, the very act of believing in the possibility of white holes is an act of hope, the kind of hope that science, too, allows itself sometimes. It is the hope that nothing in nature is truly one way, that even the deepest abyss may have a light on the other side. This hope is not naive. It doesn't deny the vastness or the harshness of space. Instead, it moves softly within it, like a lantern carried through darkness. Not to banish the shadows but to make them beautiful. The possibility of white holes turns the universe from a closed story into an open one, where even destruction can be part of creation, and endings can feed beginnings. That is not just a scientific notion, it is a deeply human one. For scientists, the value lies in the challenge they pose. White holes stretch our understanding of gravity, time, and entropy. They force us to think about reversibility, about whether information ever truly disappears, about whether the past and future are as fixed as they seem. These questions do not demand that white holes be real, they only require that we imagine them. In doing so, we make physics richer, more complete, more alive with curiosity. For the rest of us, white holes are a story not of destruction, but of release. They symbolize the possibility that nothing, not even the densest darkness, can hold everything forever. They speak of motion that cannot be contained, of light that refuses to be trapped. When we imagine them, we are imagining freedom, the universe's gentle refusal to let even gravity be purely consuming. And perhaps, somewhere deep down, that speaks to our own quiet longing for renewal. It's easy to think of science as cold, but ideas like this remind us how emotional exploration can be. The thought of a white hole of energy and light flowing outward in endless generosity feels like the universe reassuring us that it is not cruel, only complete. The black hole takes, the white hole gives. Between them, the cosmos breathes. And in that breath lies something like kindness, not in a human sense, but in the sense of balance, of things finding their way toward harmony. When you think of it this way, the white hole becomes almost like a lullaby for the mind. It doesn't insist on its truth, it only invites rest in the idea of possibility. It tells us that the universe might be more symmetrical, more forgiving, than we can yet prove. That even where everything seems to end, there may be another beginning waiting quietly beyond. The comfort it offers is subtle, but real, a scientific form of peace. In the stillness of night, when we look up and wonder what's out there, it's easy to feel small. But the possibility of white holes changes that feeling just a little. It turns the sky into a place not only of collapse but also of renewal. It whispers that somewhere, perhaps at the edge of time, the universe is giving back what it once took, not destroying, but recycling, rebalancing. A grand, cosmic kindness unfolding unseen. Even if white holes never make their appearance, their presence in our imagination changes how we feel about the unknown. They remind us that mystery is not always menacing, sometimes it is merciful. The universe doesn't need to answer every question to be kind, sometimes it just needs to leave room for wonder. White holes give us that room. Perhaps their most comforting gift is the thought that nothing is wasted. That every particle that falls, every moment that fades, every star that dies may still play a role in the endless cycle of renewal. The white hole, whether real or imagined, becomes a symbol of that eternal return, a promise that even loss contributes to something larger. This is what makes their possibility matter. It is not proof we need, it is perspective. A way of seeing the universe not as a closed system grinding toward heat death, but as a vast, breathing organism, full of rhythm and return. Every black hole that swallows could, in theory, give birth again through its white hole twin, a cosmic heartbeat that never truly stops. Even from a purely human point of view, there's something healing in that thought. To imagine that every ending has its mirror, every silence its echo, every fall its flight, it is to make peace with the structure of existence itself. The white hole becomes a metaphor for forgiveness written in the language of space-time. It says, nothing is lost forever. When scientists model them on chalkboards or in computer code, they are not just chasing math, they are chasing meaning. They are searching for signs that the universe's deepest patterns reflect not chaos but coherence, that its rules, no matter how complex, still point toward balance. And even if white holes remain hypothetical, they confirm that such balance is not impossible. In the vast scale of the cosmos, a white hole's existence may never be proven, but its emotional truth already exists. We feel it when we watch a sunrise after a long night, when we see life return to burned fields, when we remember that the universe itself began from nothing and gave rise to everything. These moments carry the same essence, a quiet, radiant release. The possibility of white holes, then, is not just a matter of physics, it is a matter of peace. It allows us to imagine a universe that is not indifferent, but complete, one where even the darkest forces have their counterpart in light. One where taking and giving are two sides of the same cosmic rhythm. One where the story never truly ends. So, if we close our eyes and picture it, a white hole, glowing softly, giving back what was once lost, we can almost feel the symmetry of existence settle over us like calm water. It tells us that the universe, vast and strange though it may be, is not unkind. That every collapse is met, somewhere, by an opening. And that even the deepest silence holds the promise of return. That is why their possibility matters, not because they must be real, but because they remind us to believe in renewal. In the balance between falling and rising. In the quiet truth that every darkness, no matter how absolute, might one day exhale light again.